Okay, hi everyone. Now after solving some sample problems in Coulomb's law, now let's take a look at additional problems still on Coulomb's law. However, it deals with the superposition of electrostatic forces. For example, 3 or more charges are involved. Okay, so let's solve some sample problems on this one. Let's start. Okay, so let's start. 2-point charges are located on the positive x-axis of a coordinate system. Charge Q1, which has 1 nanocoulomb, is 2.0 centimeters from the origin. So it's located at positive x. And then we have charge Q2, which is negative 3 nanocoulomb, is located 4.0 centimeters from the origin. What is the total force exerted by these two charges on charge Q3, which is 5 nanocoulomb, located at the origin? So for us to be able to understand this problem better, we have to illustrate it first. Okay, so for example, we have here the coordinate system, that is your positive y, and then this is your positive x. So we have 1, 2, 3, then 4 cm. Now one charge is located at this point, which is 2 centimeters from the origin, and then another charge is located at this point, which is 4 centimeters from the origin. Then you have another charge which is found at the origin. Then we are looking for the net force on this charge. So you have here Q1. Okay, let's have Q1. According to the problem, we have Q1 is equivalent to 1 nanocoulomb, 2 centimeters away. So this is 1 nanocoulomb, positive 1 nanocoulomb. And then you have the other charge, which is Q2. Q2 in the problem, it has a charge of negative 3 nanocoulomb. Okay, negative 3 nanocoulomb. And then we are looking for, take note that in the problem we have here, what is the total force exerted by these two charges, by Q1 and Q2, on charge Q3. We are looking for, even though they are interacting with one another, let's say Q1 interacts with Q2 and then Q2 interacts with Q1 and so on, we have to look into the net force exerted on Q3 by those two charges. So we are looking for their force exerted on 5 nanocoulomb Q3. So you have here Q3, 5 nanocoulomb. Q3 is 5 nanocoulomb. So it's very important to know the interaction of charges. Like for same charges, they repel, and then for unlike charges, they attract. Let's take a look at the force exerted on Q3. So let's have Q1 first. You can see here that Q1 is positive nanocoulomb. Now I want you to analyze what is the direction of the force exerted by Q1. Since this one is positive and then this one is also positive. Since it is repelling Q3, it's like it's Q1 pushing away Q3. So, tinutulak papalayo ni Q1 si Q3. Take note of that. Therefore, you have to draw the direction which is to the left. Okay? So, this is the direction of the force exerted by Q1 on Q3. So, this is F exerted by Q1 on Q3. Okay? So, my notation, I'm using F by Q1 on Q3. And then let's take a look at the force exerted by charge 2. Analyzing this one, this is negative nanocoulomb, but looking at this, Q3 is positive, therefore there is a force of attraction. Then if we are going to take a look at this, Q2 will pull Q3. Hinihila, ina-attract ni Q2 si Q3. Okay? So, lumapit ka Q3. So, therefore, the illustration will be to the right. Okay, this one is very crucial because if you were not able to analyze it correctly, you will have a wrong answer. So take note again. Q2 is attracting Q3. That's why the force is directed to the right. And then you have here, Q1 is repelling Q3 since they have the same charges. Therefore, the force is exerted to the left. That is very important. But when we look at the summation of forces now, we no longer consider the signs. For example, you have positive Q and then interacting with negative, it will become negative. We will now consider the absolute value since we already have integrated the signs in the equation, okay? So for you to be able to understand it better, let's write down the equation. We have here summation of forces. We have summation of forces on Q3. Okay, will become, based on our illustration, we have to the right. So that is the force exerted by Q2 on Q3, which is to the right. So we have to consider now the absolute value of that. And then you have here, subtract the force exerted by Q1 on Q3 because it's towards left. So this is now the force exerted by Q1 on Q3. Okay, so this is the force exerted by 2, which is to the right. And then this is the force exerted by 1, which is to the left. Now we will write down the equation we have. That will be K. So already the absolute value. We'll no longer consider the signs of the charges. So you have Q2, Q3. Looking at the distance, we analyze here the distance between Q2 and Q3. Okay? So that is R, distance between 2 and 3. 2, 3 squared. Okay, there. Minus the absolute value of K. This is now Q1, Q3, divided by the distance between 1 and 3, which is only 2 centimeters. So we will have here the distance between 1 and 3. So that is squared. Okay. Now this is our working equation. Then later on we just have to substitute the given. So let's continue in the next page. Take note also that the charges should be expressed in coulomb, and then the distance should be expressed in meters. So we have now summation of forces on 3. We have K, positive, 9 times 10 to the 9. So that's our K. Our Q1 here in the given, our Q2 is negative 3 nanocoulomb and our Q1 is 5 nanocoulomb. So we have here negative 3 nanocoulomb is times 10 to the negative 9. So that now becomes coulombs. And then you have here 5, positive 5. That's also nanocoulomb, so that's times 10 to negative 9 again, coulombs. Then you have here, divided by their distance squared. The distance between 1 and 3 is 4 centimeters. So take note, we have 4 centimeters. 4 cm is of course moved 2 decimal places. To the left, you will have 0.04 meters. Or dividing it by 100, that will give you 0.04 meters. So this one becomes 0.04 meter squared. But take note that we have to get the absolute value of that. That is for the first part of the equation. Then you have here subtract the absolute value again, 9 times 10 to the 9. I was not able to write down the unit here. That is Newton meter squared per coulomb squared. Then the charge given Okay, then you have Q1 is 1 nanocoulomb, so that is positive 1 times 10 to the negative 9 coulomb. Then multiplied it by 5 times 10 to negative 9. Then divided by the distance between charge 1 and charge 3 is 0.02, since the given was 2 centimeters. So that becomes 0.02 meters squared. Okay, there. So that's the absolute value. Then evaluating it further, let's solve it. So you have here 9 times 10 to the 9, or 9 exponent 9, times negative 3, exponent negative 9, times 5 exponent negative 9, divided by 0.04 squared. So you will have a negative 84.38 times 10 to negative 6, or we just have to get the absolute value. That becomes 84. Let's limit up to 2 decimal places. So we have 84.38 times 10 to negative 6 newtons. So why newtons? Since you have here, okay, I'll show you the cancellation of the units. Okay, you have here coulomb times coulomb, that becomes coulomb squared, so cancel. And then you have here square meter, so cancel the meter squared, and then you cancel the meter squared. So you have the final unit for the force, which is newtons. So that is 84.38 newtons. Then minus the value of this, let's solve. 9 times 10 to the 9 times 1 times 10 to negative 9 times 5 exponent negative 9 divided by 0.02 squared. Then you will have an answer which is negative 112.5 times 10 to negative 6. Okay, unit is newtons. Now let's solve for the final answer. We have negative 112.5 times 10 to negative 6 plus 84.38 times 10 to negative 6. Our answer now becomes negative 28.12 times 10 to negative 6. Okay, newtons. Okay, this is our answer. Negative 28.12 times 10 to negative 6. So that means, going back to this illustration, that the net force is to the left. Okay, let's now illustrate the net force. Let's use green one. The net force now, the summation is forces is towards the left, or to the left. Okay, so the interaction, the higher we have here, the force exerted by 1 on 3 is actually higher compared to the force exerted by 2 on 3. It is because Q1 is closer than Q2, even though Q2 has higher magnitude, which is 3 nanocoulomb. Okay? Okay, for the next item, we will be using the same given. We have Q1, Q2, and Q3. Same distances and then same charges. Now, let's try to get the summation of forces on Q1 exerted by Q2 and Q3. Okay, so let's now have summation of forces. Let's have summation of forces on Q1. Okay, net force on Q1. We have here, let's analyze the direction of the forces. Since we have here positive, this is positive. So what will be the interaction if you have two positive charges? Okay, the interaction is that there is repulsion. Therefore, Q3, itutulak niya si Q1. The direction of the force exerted by Q3 on Q1 is to the right. So let's illustrate it to the right. So this one is the force exerted on Q1 by Q3. So that is on 1 by 3. Then you have here Q2. How about Q2? Q2 is negative, but Q1 is positive. So Q2, there will be a attractive force. Q2 will attract Q1. So it is to the right. Kasi hihilahin ni Q2 si Q, inihila ni Q2 si Q1. Okay? So this is also to the right. That is the force exerted on 1 by Q2. So again, you have to analyze the illustration first before you can come up with the correct equation. So we now have here, the summation of forces on 1 is equal to, since they are both to the right, so that is the force exerted by 3 on 1, or exerted on 1 by 3, and then plus the force exerted on 1 by 2. Take note of our notation. I am using a notation wherein this is the force exerted on 1 by 3, and then the force exerted on 1 by 2. Because other books use the other one wherein they have force exerted by 3 on 1 and force exerted by 2 on 1. Okay, it's up to you on whatever notation you wanted to use. But make sure that the direction of the forces are correct. Okay? So you have here F on 1 by 3, and F on 1 by 2. So we now have the absolute value again. We have K, Q1, Q3, divided by the distance between R1 and 3 squared. And then plus, we have another K, Q1, Q2, then divided by the distance, which is R. We have here distance of 1 and 2 squared. There. So let's now substitute the given. We have summation of forces. Let's substitute the given on 1 is equivalent to 9 times 10 to the 9. Okay, we have 1. Q1 is 1, then Q3 is 5. 1 nanocoulomb and 5. So we have 1 times 10 to the negative 9 coulomb. And then we have 5 times 10 to negative 9 coulombs. Their distance is 0.02 meters squared. You have to get the absolute value of that. And then plus, we have 9 times 10 to the 9 Newton meter squared per coulomb squared. Then you have here 1 times 10 to negative 9 for Q1. Okay, you have for Q2, negative 3 times 10 to negative 9 coulombs. Okay, so looking at the distances you have here, it's correct that you have the distance between Q1 and Q3 is 0.02. So let's check. And that's 0.02. But looking at now the distance between, let's take a look at the distance between Q1 and Q2 is no longer 4 centimeters, but it's 2 centimeters only since Q1 is at the center. So we have 0.02. We also have 0.02 centimeter. Then you have to square it. Then we will take the absolute value of that. Solving it further, we now have nine exponent 9 times 1 times 10 to negative 9 times 5 times 10 to negative 9 divided by 0.02 squared Okay, for the first one we have 112.5 times 10 to negative 6 newtons plus, let's solve the other one, we have 9 exponent 9 times 1 exponent negative 9 times negative 3 times 10 to negative 9 divided by 0.02 squared. Then you get the absolute value, so that will become plus 67.5 times 10 to negative 6 newtons. So adding the two, we have our final answer is, it's equivalent to 180 times 10 to negative 6 newtons. Okay, and that one is positive since we have analyzed earlier that the net force is directed to the right. Okay, so our answer is positive 180 times 10 to negative 6 newtons. That is now the net force exerted on charge 1 by Q2 and Q3. Okay, so let's have another item. Okay, so let's take a look at this. Two equal positive point charges, Q1, Q2, equals 2 microcoulomb. So micro, recall that micro is times 10 to negative 6, are located at x equals 0, and then the other charge is located at x equals 0, y equals 0.30, and then the other one is located at x equals 0 and y negative 30, respectively. What are the magnitude and direction of the total electric force that these charges exert on the third point charge, which is located at y is equal to 0, x equals positive 0.4 meters? Okay, so we have to illustrate that problem. Okay, we have here y and x. Then the charges are located, one charge, Q1, is located at x0, y plus 0.3. So let's have this one as 0.3. We have here Q1, which is equivalent to 2 microcoulomb. Okay. And then the other one, it's located at x equals 0, negative 0.3. So they are at the same distance here. We now have Q2. Let's have Q2, which is equivalent to 2 microcoulomb also. And then we are looking at the net force exerted on this charge for microcoulomb at positive x equals 0, at x equals positive 0.4 and y equals 0. So we have here 0.4, and then you have Q3, and you have here Q3 is equivalent to 4 microcoulomb. Q3 is equivalent to 4 microcoulomb. And then the distance here is 0.4. Then you have the distance here is 0.3. Then another 0.3 here. So you can see now that the problem that we have here is in 3 dimensions. So we have charge here, Q1, Q2, and Q3. We are looking at the net force on Q3, okay? So to illustrate it better, let's have Q1, Q2, then at the center here you have Q3. Now let's analyze the direction of the forces. We have Q1, let's represent, or let's use red. Q1 is positive and Q3 is positive. Therefore, what is the direction of the force exerted by Q1 on Q3? Okay, the force exerted on Q3 by Q1 is repulsion. So it's like pushing Q3. Therefore, the direction is patulak, which is diagonally down. Since we have positive and positive. And then another one, Q2, which is also positive, and then Q3 is positive. Therefore, the force here exerted would be in that direction. Okay? So we now have the summation of forces along X and along Y. If we are going to analyze it, what will be the summation of forces along Y? Since they have the same charges, okay? So let's just have it one by one. We now have here the Y component. Let's use the red one. We have here the Y component, which is downward. And then we have here the X component. Anyway, you're given the distances along X and along Y. And then for the blue one, we have the Y component, which is upward. But the X component is to the right. Okay? So let's have the summation of forces along Y first. Summation of forces along Y. So you can see here, the force exerted by Q1 on Q3, you can see that it's downward. Okay, since it's downward, it is negative. So you have here equals negative, the force exerted by, or exerted on 3 by 1. And then for this one, since it's upward, you can see here it's upward. Then you have the plus, force exerted on 3 by 2. So here we now have summation of forces along Y. We have negative K, the absolute value of K, Q3 and Q1, divided by, we have the distance between 1 and 3 along Y. Okay, we have distance of 1 and 3 along Y squared, that is along Y. Then we have plus K, Q3, Q2, divided by, we have the distance between 3 and 2 along Y squared. Okay, we get the absolute value of that. And then substituting the given, we have negative 9 times 10 to the 9. Q3 is 4 times 10 to negative 6. Q1 is 2 times 10 to negative 6. Then you have the distance along Y, it's 0.3 squared. And then, absolute value of that. But we have negative sign outside the absolute value. Then plus, K is 9 times 10 to the 9. Then Q3 is 4 times 10 to negative 6. And then you have Q2 is 2 times 10 to negative 6. Then the distance, they are the same, so it's 0.3 also squared. Okay, so you can see here that they will have the same value. So this becomes negative and then this is positive. Therefore, the summation of forces along Y is equal to 0. So we can now have here that the summation of forces along Y is equivalent to 0. So we now analyze the forces along X component. Okay, so you have here, looking at the illustration again, at this point, the force exerted by Q1 on Q3 is to the right, And then also the force exerted by Q2 on Q3 is also to the right. Therefore, we just sum them up, and then we consider the distance along X. Okay, so you have summation of forces along X. So we now have here the summation of forces along X. We have now the force exerted on 3 by 1. Okay, and 3 by 1, and also along X, plus the force exerted on 3 by 2 along X. So let's check. We now have here K, absolute value K, Q3, Q1, and then you have the distance between R13 along X squared plus K, Q3, Q2 divided by the distance between 2 and 3 along X squared. Okay, so you have 9 times 10 to the 9 our Q3 is 4 times 10 to negative 6. Then you have our Q1 is 2 times 10 to negative 6. Divided by the distance in between them is, along X is 0.4 squared. Okay, there. And then you add 9 times 10 to the 9 again. We can actually factor out the 9 times 10 to the 9. Then you have Q3 is 4 times 10 to negative 6. And then you have Q2 is 2 times 10 to negative 6. Then the distance between them is also 0.4 along X squared. So solving it, we now have Solving it, we now have 9 times 10 to the 9 times 4 times 10 to negative 6 times 2 negative 6 divided by 0.4 squared. Then we can just multiply it by 2 since they are the same. So our answer is, we have here 900 times 10 to negative 3. So that's 900 times 10 to negative 3, or 0.9. So 900 times 10 to negative 3 newtons. Or we can also express it as 0.9 newtons. And then it's also, the direction of that is towards right. Okay? Along the Y, the forces cancel out. So the summation of forces along Y is 0, but the summation of forces along X is 0.9 newtons, which is positive, or to the right. Okay? So next. Okay, let's have the next item. 3-point charges are arranged along the x-axis. Charge Q1 is 3 microcoulomb at the origin, and Q2 is negative 5 microcoulomb, is at x equals 0.2 meter. Charge Q3 is equivalent to negative 8 microcoulomb. Where is Q3 located if the net force on Q1 is 7.0 newtons in the negative x direction. So let's analyze where is Q3 located. Okay, we now have here, at the origin, we have Q1. So let's say this is our origin, where Q1 is located. That is 3 microcoulomb. Okay, that's positive 3 microcoulomb. And then Q2, which is negative 5 microcoulomb, is at X. Let's say this one is 0.2. This is our origin. And then you have here 0.2 meter. We have Q2 is negative 5 microcoulomb. Now, where is Q3 located if the net force on Q1 is to the negative x direction? So, the net force is to the negative x direction, therefore it's to the left. Okay, looking at this is positive. Okay, looking at this is Q1 is positive, then Q2 is negative. Therefore, the force exerted on Q1 it's an attractive force. The force exerted by Q2 on Q1 is to the right. Q2 is attracting Q1. Now, Q3 is negative. This is positive. So, we are expecting that Q3 is also attracting Q1. Since one is negative and then the other one is positive. And the net force is equivalent to, or the net force is to the negative x direction. Can we have Q3 at this point? If lalagay natin si Q3 at this point, if Q3 is to be placed here, magiging attraction din siya. Therefore, the net force should be to the right. So that is already wrong. Could no longer have that. If we are also going to place Q3 here, since it's negative, the net force is also to the right. Hihilahin niya si Q1. So that is again a wrong position of Q3. Then we can expect that Q3 is at this point or at the left. So that when Q3 is here and it's negative, the force exerted by Q3 will be to the left. But we will look for the distance. We now know that it's to the left or it's on the left side, but we don't know the distance. Okay, so we are to look for that distance since we now have the net force. Okay, so let's now have the equation. Okay, we now have the summation of forces on Q1. Okay, looking at the illustration again, the force exerted by Q2 will be to the right. So we can have here, it's positive force exerted on Q1 by 2. And then you have here, to the left, is the force exerted on 1 by Q3. So we have minus the force exerted on 1 by charge 3. Okay, so this is our working equation. Then we can now have K, Q1, Q2 over R12 squared, then minus K, Q1, Q3 divided by R13 squared. So we are looking for the R13. And then, take note, we have here the net force is 7 newtons and it's to the negative. Then we have here negative 7 newtons. Are the signs consistent? So you have here, it's to the right. The force exerted by Q2 is to the right, and then the force exerted by Q3 is towards left. Okay, so that we have a negative net force, negative 7 newtons net force. So let's now have 9 times 10 to the 9, substitute the given. Our Q1 is 3 microcoulomb. and then Q2 is negative 5. We have 3 times 10, negative 6 coulombs. And then you have Q2 is negative 5. So that's 5 times 10 to the negative 6 coulombs. Then absolute value of that divided by the distance R12. The distance between 1 and 2 we have here. 1 is at the origin and 2 is 0.2. So the distance is 0.2 squared. Okay, there. And then you have here minus K, which is, I'll just write it here. Then you have here minus 9 times 10 to the 9. Absolute value again. Then Q1 is 3 times 10 to negative 6. And then you have here Q3 is negative 8. Q3 is negative 8 times 10 to negative 6. Divided by, okay, we are looking for R13. Then you have squared there. Now let's evaluate the given. Okay, so let's now evaluate this. We have 9 times 10 to the 9 times 3 exponent negative 6 times 5 or negative 5, but we get the absolute value later, exponent negative 6 okay, the divided by 0.2 squared. So you now have here 3.375, or let's have 3.38. Okay, we now have an equation, negative 7 equals 3.38. And then you have, for this one, let's evaluate that. The numerator, we have 9 exponent 9 times 3 times 10 to negative 6 times negative 8 times 10 to negative 6. Okay, it's 216 times 10 to negative 3, or 0.216. But we have to take note of the negative here. So that's minus, we get the absolute value of this. So that's minus 0.216. So we will express up to 2 decimal places. We'll just have minus 0.22 divided by, we are looking for the distance R13 squared. So that is R13 squared. So evaluating this one further, let's subtract 3.38 on both sides, so minus 3.38. So we can now remove 3.38 here. And we now have here negative 7 minus 3.38 equals negative 0.22 divided by R13 squared. Since we are after the distance 13, we multiply everything by R13 squared. We now have here R13 squared equals negative 0.22. Then we divide it by this value, which is negative 10.38, negative 10.38. Then we get the square root of both sides to have the answer R13. So we now have here, let's write it here, R13 now is equivalent to, let's solve, 0.22 divided by 10.38. Then you get the square root of that, Okay, again, 0.22 divided by 10.38. Get the square root. Okay, we now have 145 or 146 times 10 to negative 3. So that becomes 0.146 or 0.15. Our answer is, since the root will be positive or negative, 0.15. But because of our analysis earlier, so you can see here, we are expecting that Q3 is located at negative x. Therefore, our final answer is, the distance is, or it's located at negative 0.15 meters. So R13 now is equivalent to negative 0.15 meter, or it's located to the left of Q1. Okay? So to check if our answer is correct, of course, you solve the net force if you will get a net force which is negative 7 newtons. Okay? So you try to check our answer, negative 0.15 meters, to check if you will have a net force of 7 or negative 7 newtons. Okay? So try it. Okay, so let's have this last item. Here you have here in the illustration, Q2 is found at the origin, and then Q1 is located 52 centimeters away from the origin. Q1 is negative 86 microcoulomb. Q2 is positive 50 microcoulomb. And then you have Q3, which is positive 65 microcoulomb. Q3 is located 30 centimeters above Q2. Now the question here is to solve for the net force on Q3 by the charges Q1 and Q2. So again, this is a three-dimensional problem. So let's take a look at the forces acting on Q3 first. Okay, let's analyze the direction of the forces. You have here Q2 is positive and Q3 is positive. Then of course, Q2 will be pushing away Q3 kasi the force is repulsion since they have the same charges. So the force exerted by Q1 is upward. Looking at this one, Q1 however is negative, therefore there is a force of attraction. Then Q1 will attract Q3 or will pull Q3. So this is now the direction of the force. So this is now the illustration of the force exerted on 3 by 1. This is the force exerted on 3 by charge 2. Now let's take a look at the summation of forces or the forces exerted by Q2 on Q3. Okay, so let's now substitute the force exerted on 3 by 2. We have K, absolute value of K, Q3, Q2, divided by R23 squared. So that's the distance between 2 and 3 squared. So this one is upward, that's why it becomes positive. So let's now substitute. We have 9 times 10 to the 9. Our Q3 is 65 microcoulomb, so that's 65 times 10 to negative 6 coulombs. And then you have here Q2 is 50 microcoulomb also, so that is 50 times 10 to negative 6. Okay, divided by the distance between 2 and 3, that's along y, that's 30 centimeters, so it becomes 0.3 meters. You have here 0.3 meters squared. This is the force exerted on 3 by charge 2, and that is equivalent to, okay, let's try, 9 times 10 to the 9 times 65 times 10 to negative 6 times we have 50 times 10 to negative 6 divided by 0.3 squared. That will give us 325 newtons. Okay, that is only exerted by 3 or on 3 by 2. Now let's analyze the force exerted by 1 on Q3. Now we have here the illustration. Okay, we have here the illustration is this. The distance is 60 centimeters. Then you have here Q3 positive. And then you have Q1 which is negative. Now the direction of the force again is attraction, so it will attract, Q1 will attract Q3. So let's now solve for the force exerted on 3 by 1. So you can see here, the absolute value for that is K Q1 Q3 or Q3 Q1 divided by the distance is between 3 and 1 squared. So we now have here 9 times 10 to the 9 Newton meter squared per coulomb squared. And then our Q3 is 65 microcoulomb, so that's 65 times 10 to negative 6. So we have 65 times 10 to negative 6. And then for Q1, it's negative 86 times 10 to negative 6. Since it's also microcoulomb, then the distance is 0.6 meters. That will become 0.6 squared. And then we take the absolute value of that. The force exerted on 3 by charge 1 is equivalent to, the absolute value is 139. Okay, so solving for that, 9 times 10 to the 9 times 65 times 10 to negative 6 times negative 86 times 10 to negative 6 divided by 0.6 squared, then we get the absolute value that becomes 139.75. But we haven't resolved this one yet to its x and y components. So let's take a look at the x and y components. Okay, looking at the illustration again, you can see here that the force which has an x component is the force exerted by Q1 on Q3. The force exerted by Q2 has no x component. So we will just consider the force exerted by 1 on 3. Summation of forces along x. So you have here summation of forces along x. And the only force acting along x is the x component of force on 3 by 1. Now, I was not able to draw the angle, so you have here the angles. You have 90 degrees here, and then you have here 30, and then you have here 60. So we have here F31x. If we will consider this angle 30 degrees, the x component is the adjacent side. Therefore, we will be using cosine theta. We now have F31 cosine 30 degrees. So earlier, we have F31, which is 139.75 times cosine 30 that will now give us a value of 121.03 newtons. That is for the summation of forces along x component. Now let's look at the summation of forces along y. Looking at the illustration here, we have two components for the y. One is the force exerted by 2 on 3, and then the other one is the force exerted by 1 on 3 along the y component. So let's have summation of forces along y. So let's have summation of forces along y. And the force exerted on 3 by 2 is upward, but the force exerted on 3 by 1 is downward. That's along y component. So you have here summation of forces along y is positive for the force exerted by 2. So that is the force exerted on 3 by 2 y. But you have negative for the force exerted on 3 by 1. Okay, y component. So substituting it, we were able to compute earlier the force exerted by 2 on 3, which is only along y component, and that is equivalent to 325 newtons. But for F31y, we have to have F31. Since y is the opposite side, we will be using sine, and then we will use this angle. So F31 sine 30 degrees. So you now have 325 minus 139.75 sine 30 degrees. Therefore, calculating this, you have 325 minus 139.75 times sine 30. It will give us a value of 255.13 newtons. So that is now our summation of forces along y component. But since we are after the net force, we have to get the final force and also the angle in which the force is exerted. Or in which the net force is exerted. Okay, then recall getting the resultant we have. If we wanted to get F, we have square root of the x component squared plus the y component squared. The calculation that we had, for the x component we have here, 121.03 squared and then for the y component we have here we have 255.13 squared. Okay, there. Then we have square root of 79.74 times 10 to the third. So getting the square root of that, we will have now the force which is equivalent to, or the resultant force, which is equivalent to 282.4 or 0.14 newtons. Okay, since force is a vector quantity, therefore we have to get the angle. Then recall that in getting the angle, inverse tangent, we have inverse tangent ry over rx, or fy over fx. So in this problem, we have inverse tangent. Our fy is 255.13. That's positive. Divided by our fx is also positive, which is 121.03. So let's solve. inverse tangent 255.13 divided by 121.03, that will give us an angle of 64.62 degrees. Okay? So our final answer, the net force exerted on charge 3 or Q3 is equivalent to 282.40 newtons, and the angle for that net force is 64.62 degrees. Alright? So that will be the end of our problem solving on superposition of electrostatic forces. Okay? So see you in the next lecture. Bye everyone!